All right, it's following us. First day of the swivel. We're in Algebra 2, Lesson 2-3, Evaluating and Graphing Functions. I'm your host, Mr. Sindel, and today is the 5th of October, 2023. Quiet raised hand. Objective. Who wants to read it? Riley was first.
Evaluate points and use points to graph.
There it is. You just plug it in points over and over again, and you'll get the general idea of the graph. All right. Let me first explain function notation. So function notation means that I have a letter with an x. So I say f of x is maybe, I'm just going to make up x squared plus 2x plus 1. This is a function. Do you guys know the difference between a function, expression, and equation? Oh, the swivel will track me over here. Oh man, this is kind of nice.
Oh, no.
Oh man, I went too fast. There it goes. Come over here, swivel. Here, boy. Here, boy. All right.
So fun.
A function has some sort of f of x with an equal to sign. An expression has no equal to sign, and an equation has an equal to sign without function notation. So today we're talking about the blue, which kind of mixes with the yellow a little bit, to make a function. All right? Oh man, it's following me. Good boy, swivel, or good girl, I don't know. So when we plug in points, this is how you show that. Let's go ahead and plug in the point 0. If I want to evaluate this thing when x is 0, so at x equals 0, here's how you write that. I don't know what the y coordinate is, but I know the x coordinate is 0. I'll now say not f of x, but f of 0. Very nice. Every single one of these x's is turning into a 0. That's what this meant. I'm plugging in 0 for x. So this is going to turn into a 0 squared. And the parentheses here are super duper important, especially when we have negatives. I can do an example in a sec where those are really important. 0 squared plus 2 times, okay, here's my x. It's 0. Then I'm going to write the plus 1. This is the exact expression, but everywhere that there was an x, I've switched it out for a 0. And because I'm doing substitution, I'm leaving my parentheses. Yes?
Can the x be any number? Like if it's a 5, like x equals 5?
It could be f of 5. Yeah, we'll do that maybe next. All right, but let's go ahead and evaluate this thing. Okay, I have f of 0. What is this thing really equal to? 0 squared, everyone shouts out.
0.
Plus 2 times 0.
0.
Plus 1.
1.
F of 1 is 0. So here's how you read function notation. You say that the x coordinate is 0 and the y coordinate is 1. F of 0 equals 1 gives you both the x coordinate and the y coordinate. There's the x coordinate, there's the y coordinate. This is the same thing as if I told you it's 0, 1. These mean the same thing, but not only does this tell you it's 0, 1, it tells you which function it belongs to. This belongs to f. I can evaluate at a different point. You wanted to do 5, right, Riley? Let's do it. If I have f of 5, okay, this is our normal f of x function. I'm going to rewrite this, but in this spot where there's an x, I'm going to leave an empty space. This is x squared plus 2x plus 1. I've rewritten this exactly, leaving a space for the x, but instead of an x, it's a 5. So we just write 5, 5, and then I evaluate. Ready, set, quiet raised hand. Who can evaluate all this for me? For participation card. Charlie, participation card. I'll take it.
What do you want me to do?
I want my participation card.
Oh.
Your participation card. I've got your participation card, and I'll put that right there. Go.
25
25
plus 10 plus 1.
plus 1. Keep going.
36.
So I say that f of 5 was this. F of 5 is this. So that means that the x coordinate is 5, the y coordinate is 36. This one line right here means 5, 36.
Then we would graph it.
And then so that's the first part of the objective. I just want you to be able to say, hey, plug in a point. That's the first part of the objective. Can you evaluate points? I evaluated our function at 5, and the output, the height, the y coordinate is 36. First part of the objective, good job. Question?
Would you reduce? Like if if that was like 2?
If what was 2?
If it was like f of 2, would you reduce?
F of 2.
Make it 1 and...
Oh, no, no, no. This is the x-coordinate. The x-coordinate, it's not a fraction or anything like that. Yeah, that's a good question. Okay, let's put these pieces together for the second part of the objective. I want to use these points to graph. So I'm going to do a brand new function just to practice this. So I'm going to make this example. Technically, these were examples, weren't they? That was explaining function notation. I'm going to officially call this one example 1, though. I want you to graph g of x. Notice that it's not f of x anymore. I've switched the letter. G of x, and that's going to be equal to, what does the classwork look like? Ooh. We're going to do the absolute value of 2x minus 1 and absolute value plus 3. And I'm going to be specific here. I can give you discrete or I can give you continuous because we're trained on both of those from lessons 2-1 and 2-2. So I'm going to make this one discrete. What does discrete mean?
What's the difference between G and F?
They're different letters. I know, very crazy. They're just different functions. I can graph them on the same, like if I had a graph here and one of them was woo and one of them was woo, you'd be like, that one right there. Because normally we just have y and y. Those are the functions. But instead of having y, I can talk about them each and say, this is f of x and this is g of x.
Gotcha.
So I can point, oh, this is the f of x, that's the g of x. It's just distinguish between the functions. All right, so for this guy, we're going to plug in points and see what happens. Essentially, we're making a table, and then we're going to plug it in. So I highly recommend making a table, x, g of x, and see what happens. What's the number that you want to plug in? I suggest the easiest one as possible. What's the easiest number? 1 is a nice, easy number. If I plug in 1, then I'm going to rewrite all of you. I'm going to say 2 times 1 minus 1, all in absolute value, then plus 3. Okay, keep evaluating. 2 times 1. I need a person to participate. Riley, do you have your card still? I'll take it. All right, you're doing all this. 2 times 1 minus 1. What's the absolute value of 1? 1, and then plus 3. That means I'm going to be graphing 1, 4. Okay, what's another value that you want to try to evaluate at?
3.
3, okay. It really doesn't matter what we have here. Oh, I forgot to talk about the difference between continuous and discrete, though. What is the difference between continuous and discrete? Continuous means you don't pick up the pencil. Discrete. Yeah, so let's make this one a discrete function. I will tell you something like this. The domain for this problem is, how do they list it on here? Is a set of numbers 0, 1, 2, 3, 4. When it gives you a discrete domain, it's telling you what your table value should be. I need a 0, 1, 2, 3, 4. I've done 1. I'm about to do 3. Let's make sure we have all of them. Let's do 2 next, and then we'll come back to 0 at the very end. So I need to do a 2 there, a 3 there, a 4 there, and a 0 there. All right, lots of participation cards. Who's doing this one? Who's going to do 2? Raise hand. Estrella wants to do it. Yeah, she does. All right, it's going to be absolute value of 2 times 2 minus 1 and absolute value plus 3.
4, 3, 3, plus 3, 6.
You're able to follow that, guys?
Yep.
All right. Next, I've got 3. I'm plugging in 3 into this x. It's going to be absolute value of 2 times 3 minus 1 plus 3. Who do I not have? Julian, go for it.
5, 5, 8.
And then finally over here, I have, well, not finally, I have a bunch of them, don't I? 2 times 4 minus 1 and absolute value plus 3. By the way, you guys can probably see the pattern. You guys see it? Plus 2, plus 2, plus 2. This one's probably going to be 10. Let's double check that. Julian, go for it. Oh, wait, Julian just did the last one. I need your card, though, don't I?
do it.
All right, Mia.
2 times 4 is 8 minus 1 is 7 plus 3 is 10.
There it is. Nice. What do you think is going to happen when I hit 0? That would be going back this way. Instead of adding 2, it would probably be subtracting 2. What do you guess it's going to be? It's probably going to be 0. Let's test to see if this, or 2, sorry. I miswrote what you said. Let's see if this works. So it's going to be absolute value of 2 times 0 minus 1 and absolute value plus 3. Another quiet raised hand. Hey, Aaron, go for it. Yeah. Absolute value of -1. Oh. We were wrong.
Oh, oops, I did +1.
Interesting. We thought it was going to be 2. But it's actually 4. Weird. Yeah, that's... the pattern is it's a V shape. So what I'm trying to get across from this lesson is it doesn't matter what sort of function I throw your way, but you should be able to roughly graph them. So I'm going to go ahead and graph this one really quickly, and I'll explain why this happened instead of this. All right, so my x comma y, 1 comma 4. So Mia's going to try her best to make a graph. I'm going to go 1 to the right. I'm going to go up 1, 2, 3, 4, and I make a point. This point right here is this point right here. Fist of 5. Do we understand? Good. You have participated. I get your card. All right. To make sure, David, do you still have your card?
Yeah, I think I'm the only one that doesn't.
You and Julie, right? David, give me 2 more points. I have 1 comma 4. Give me another one. 2 comma 6. So I'm going to go 2 comma 6. Give me one more, David. 3 comma 8. 3 comma 8.
How many up is that?
I just graph 3 comma 8, 2 comma 6, 4 comma 10, etc., etc. Julie, give us the last 2 points on here. 4 comma 10 and 0 comma 4 is right there. Weird. It's like a check mark weird thing. To show you what would have happened, I'm going to extend my domain and make the problem a -1. What do you think is going to happen if I plug in a -1?
Well, go to negative, or negative 2.
So right now we're at a height of 4. Do you think it's going to go down to -2? When I plug in this x coordinate right here, where on this dotted line, this dashed line, do you think I'm going to have the height? So it's going to go here and then just jump down. Positive 6. Okay, let's see. If I have absolute value of 2 times -1 minus 1 plus 3. Charlie, go for it.
-2 or -3. 0.
No.
-3, absolute value of 3. Absolute value of -3 is 3. 3 plus 3 is 6. It went back up to 6. Went back up here. And here's why. Absolute values look like V's. So we're done. That is the answer. That's what you should have graphed. But if I were to change this to make the domain between -1, and I'll say, we'll say you can be equal to 1, but we go to 4, and it's continuous, all the values in here, then it changes to a continuous function where I cannot pick up the pencil, and it will go like this. Absolute values are V-shapes. It's as if I have a mirror and I reflected a light beam. The mirror is right here, and the light beam, the laser pointer, came down, reflected off the mirror, and started bouncing back up. That bouncing happens because of the +3. We move the mirror up 3, so it bounced up. So this one is called continuous. This one is called discrete. Discrete will just have a bunch of points. If it's continuous, it will be a line. Continuous are the harder between the two because you actually have to connect the dots and know that there was a hidden point right here. If I plugged in a half, I would have come down to a height of 3 instead of a height of 4.
So like on the homework in classwork, do we have to graph it? Like make
Wait,
a graph?
why is the lowest point lower than where the other two are?
Because it was not in the original discrete domain. What we should have had was a number in here like a half. If we plugged in a half, and you guys can do this with me, watch. 2 times a half is
The
One.
1. 1 minus 1 is
0.
0. Absolute value of 0 is
0.
0 plus 3 is a height of 3.
Oh.
It just, 1/2 was not in the discrete domain. Once I make this function continuous, then not only do I have the dots, but I connect the dots. So the hardest type of function I'll give you is, I'll give you a function like h of x is equal to something. You make a table of points, you graph the points, and then connect them with a line. All right, so that was using the points to graph, the second part of our objective. Now, for our entire objective, evaluate points and then use them to graph. What's our fist of 5 on our objective? I've got a 4, a 5, a 5, a 5, a 4, 4, shaky 4, and a 4. All right, thanks.